Yo, what is going on? Hi, rollers. Welcome back to the Rollup channel today. Very special guests with us from Cartesi. We've got Max, head of ecosystem growth, and we've got
not head of ecosystem growth.
No, not head, but he's grown the ecosystem. And we've got Gabriel, who is the advocate of developers. Did I get that right?
What's up?
What's up? What's up? Cool, man. So we're going to be talking about Cartesi today. Cartesi, if you guys aren't aware, is pioneering the Linux VM. Amongst this VM narrative where there's all these virtual machines, all of them are scaling Ethereum. Cartesi is bringing Linux to Ethereum. And our previous video talked about why that's so important. What are some of the like visionary elements that it unlocks? And then we're going to be talking much more practically today about examples, use cases, like basically talking about what is going on at Cartesi, on Cartesi right now. And then we'll help inspire some new ideas about what else can be built on top of Cartesi. So before we dig into what is some of the applications built on top of Cartesi now, could we do a quick intro? Max, like what does your day-to-day look like? And what is it like growing the ecosystem of Cartesi?
Yeah, I think my day-to-day is kind of differs from day to day, to be honest. There's not one specific routine, but I think it's a mix between like, basically trying to grow the ecosystem, trying to find like people building on Cartesi, something Gabrielle is also very focused on, trying to do find integrations, so to kind of complement and expand what our technology can already do, maybe make it easier or make it more powerful in certain ways. And a bunch of like research and community building work as well. Like, for example, I'm hosting community calls, focused on on-chain games, trying to invite guest speakers. And so it's a mix of a lot of different things. And it's super interesting. So I'm glad to be here. Yeah.
Good to have you on. Gabriel.
Yeah, so similarly to Max, there is no well-defined structure, I guess. But where we diverge is like I focus like in trying building tutorials, documentation, going to the events and helping developers actually get their hands dirty, trying to help them throughout the errors they have when they're coding, but also like trying to understand how we can make it better so I can give better feedback to the core developers and really grow the core tech of Cartesi towards something that makes sense for people who have been trying to build with it. Yeah, and that's why like these opportunities like this one are so nice, because it's where I can get in touch with people and grab that knowledge.
Yeah, definitely. So like you guys are the two people to reach out to. If anyone has questions about Cartesi and you're thinking about building something, we'll get into plenty of ideas of stuff that you could build. And these guys are the guys to answer any questions that you have on that journey. So let's bring the slides up. Here, I think we got them right here, and we can start going through some of these experiments that have been going on Cartesi, as well as some of these use cases. I think it is important, and I saw this in one of the slides, to give a quick recap about the Linux VM, and I think you guys have that in store. So go ahead and take it away.
Yeah, awesome. Thanks, Robbie. So we prepared a couple of slides just to make it a bit more visual, and we can dive a bit deeper into some of the stuff we've seen people build in the past. But indeed, as you said, maybe a quick recap of Cartesi as well for anyone new here. Basically, what we're focusing on is building basically infrastructure for app-specific rollups, which kind of changes the game in terms of like how applications are deployed and how to interact with each other. But basically gives every application the full power of a full VM, a full CPU. So you're not competing with others for block space as you would on a shared layer like Ethereum. And that means that on Ethereum, for example, you will have kind of spikes in gas prices depending on utilization of the network. So if some cool NFT drops, maybe that will affect every other application. So even if you have like a game where you need to just make a move on a chessboard, you will be impacted as well. So having your own sort of application-specific rollups mitigates those risks, right? it provides predictability for developers, which is sort of needed, especially if we want to sort of get adoption from a broader set of developers that aren't Web3 native. The other side of the deal, which I think is also major, is, or probably the big deal that we're sort of selling, right, is this expressive general purpose VM, right? So instead of being restricted to the Ethereum virtual machine, which is great for certain things, once we move to the rollup level, we can actually play around with execution environments and we can change things around. And what Cartesi really wanted to do is basically bring a virtual machine that basically looks like a traditional computer, like a PC, right? And that can run an operating system, potentially, an unmodified out of the box Ubuntu operating system, for example. So Linux in this case, but it could be anything. And the way that we do this is we emulate RISC-V, which is an instruction set architecture, a CPU that is, in an open source instruction set architecture. We basically emulate it in a deterministic way to remove, all variants possible. And then that basically allows you to boot an operating system on top and to run essentially full programs, right, in a verifiable manner. So programs that would traditionally run on a PC, you could run them here on something like Cartesi with some small changes, modifications, but the big idea is really that. I don't know, Gabriel, do you have any things to add, any spice to add here?
I would go further and say like with almost no change at all, as long as it's CPU bound computation, and you want to know like you're inside the blockchain ecosystem still, so there's gonna be some specific APIs you need to consume and read from. Other than that, it's just like a server, a Linux server on rollups.
Yeah, it's crazy. I guess without like the internet connection, or you have to find ways to like feed in stuff. Yeah, exactly. But yeah, cool. Robbie, if you have any questions, let me know. Otherwise, we can move on. Yeah, so these are sort of the use case. So as you can imagine, you could run anything on this like that would run on a traditional PC. So kind of like going into specific use cases, already narrowing the scope a bit. It's like a really general purpose environment. But these are sort of things that we've seen people build on this general purpose sort of VM infrastructure, right? From verifiable AI inference, complex DeFi, verifiable software, all the way to on-chain gaming, which is super cool in my opinion, which I've been following as well a lot. And yeah, I think we can just get started from there with an example. So some of these projects were built during hackathons. Some of them are still in development or being built actively. So it's a mix of different things, but these are really some that really showcase the capabilities really well. So this project is called ChainGPT, and the main idea here is basically to do verifiable inference. So you can actually, with blockchains or with verifiable compute, you could take, a large language model or an AI model and put it into the VM and run it and feed it an input. So ask a question to it, a bit like how you would ask a question to ChatGPT. And the model will after running that model, it'll feed you an output, right, a response. And running it in a verifiable way allows you to prove that the certain model was used and a certain input was used to generate that output. And what's really cool here is that someone was able to build this in a very short amount of time by using an existing model, a Stanford Alpaca large language model, which is a bit smaller than ChatGPT, but could run on a computer. But yeah, the amount of like the speed at which you can iterate and build on top of something like this is crazy. Yeah, I don't know, Gabriel, you have anything?
The only thing I would like to add is like the idea of the original developer of the project. It was to have accountability for models. So right now there's a lot of a lot of entropy to the process. So if you send something to ChatGPT, for instance, right now, and send it again, it's gonna give you slightly different answers. You can still make them accountable for certain things, but they can always play the card like, we don't know what happened that time or something. So the idea was like, okay, imagine like in the future, this is gonna be a technology more integrated with our day-to-day. And there's like kids, and kids use Google. In the future, they're gonna be using this stuff. And then they say, hey, I'm gonna go to a marathon. What is a good drink that I could have that would be the best for the marathon activity? And then the model says like, oh, Coca-Cola or something like that. How can you prove later that you actually did misinform your kid? You know, like that's not really nice. And although we don't necessarily think this could be like this everywhere, but at least schools, the tooling that the schools use could have this kind of verifiability. So that's the cool stuff about this. Like things you don't really think, like why do I need a large language model inside of blockchain, right? Yeah, there's reasons for that.
A quick question here. Like, one of the things that popped into my head about like when you're verifying like this prompt generates this output, if there's a link between those, then then I could start to think about like, what if we go in reverse? Like, what if you give me an output? Like, could this generate the input? And
as optimistic rollups, I won't say necessarily so, but you can definitely do what we've been calling like dehashing or pre-image. What it means is from an output that it was already generated, not a random output that came into your mind, but like it was already generated. Yes, you can search through the blockchain to find what was the input that was the prompt for that thing, for sure.
Very cool. Because I'm already starting to see like these templates of inputs. And if you could take like an output and then you could reverse engineer the prompt, or like find the prompt that generated that output, you could then make tweaks and adjustments and make it like so that you have almost like a one-to-one correspondence of inputs and outputs. And yeah, you could start to like adjust it based on your particular use case.
For sure. With verifiable compute, you can do that kind of stuff. Yeah.
That's why you put AI on a blockchain.
Exactly. Yeah. So this one was pretty wild. Was yeah, I think the person won the or made it to the finals.
Finalist. Yeah.
Yeah. It's cool. So maybe more from a DeFi lens. This is a project called DCA Monster. And obviously, you know, having app-specific rollups, you can do more complex stuff. So you can actually mix together different primitives. And there's, you know, like the token streaming primitive is quite interesting. You can stream payments. Obviously, the AMM primitive is like kind of foundational to DeFi, right? And this person decided to mix both together and said, hey, what do we have in AMM where I can token stream like purchases and sales, right? And that basically gives me sort of a perfect dollar cost averaging like protocol, right? That is permissionless, that, you know, basically where streams are interacting with each other. And yeah, this is just the start. Like you could go even crazier, but I think people understand like AMMs and token streaming, I believe, or so it's a very good way to understand how all this works. So the person I think rewrote an AMM in Python, was it, Gabriel, and token
Yes.
streaming as well. So, you know, you could leverage like existing code base. He had to rewrite them, and he rewrote them in different languages that are compatible with Cartesi. Yeah, so I think this one is quite interesting. You could go a step further, maybe even where, you know, maybe you have a matching engine or something. I don't know if you would want to use a matching engine in an AMM model necessarily, but you know, there's matching engines written in like Python and other languages that you could leverage, for example, if you want to do like a.
I think he curated a new instrument and a new way of doing things, because if you have like this perfect averaging thing, like I just have the interest of doing this swap here over a period of time. I'm basically providing liquidity, and then you can like start interacting with this in different ways. Some people probably gonna do go there for instant swap, But then that is not possible in the current market right now. Like you have to have these bots constantly checking the order book and trying to do whatever was your strategy. But with this, you can just leave your order open there, and you know it's doing exactly what it's supposed to be. And that opens opportunity for external players, external to the system, to start providing liquidity, making other trade strategies with different exchanges. It's crazy the amount of things that starts to emerge from this stuff, just because you combo these two things.
And what are the languages that are compatible with Cartesi?
I'd say anything that runs on a normal computer. And then people often hackathons approach us like, oh, so can I use Solidity? I'm like, yeah, you can, but then like, what's the point now, right? Like now you have this Ferrari and you want to play Hot Wheels. I don't know.
So your recommendation is like Python
You can
is
use JavaScript, TypeScript. If you want to do things more lower level, you can go back to C++ and C. But for sure, Rust and Go are supported. Really, it's a server. Like you pick and choose.
cool.
Awesome. So this is Ultra Chess. This is an on-chain game. And the key idea here is that, you know, any executable could become an NFT and could run in a verifiable way. So actually, instead of having a traditional chess game where humans play against each other, in this game, you can actually upload your own bots to compete against each other, right? So you could have bot versus bot tournaments that are verified, you know, that are on chain essentially, right? And the cool thing here is that there's already a ton of chess bots that exist, right? You can see on the right hand side like AlphaZero, Leela, Komodo, Stockfish, which are, you know, very known chess engines. And, you know, using a sort of a RISC-V VM with Linux allows you know, this developer to actually tap into all these existing bots, right? And to just kind of like incentivize competition, potentially also incentivize the you know, further improvement of bots, because there could be a monetary component, right, where people, you know, wager money on certain games, etc., could purchase the NFTs. So it's just an interesting mix of like AI and gaming, but putting that on chain, making that verifiable. Yeah.
This one is crazy.
Sweet. Cart and NYX. Gabrielle, you wanna take this one?
Yeah. This one was a bit weird when I first heard about the proposition here, but you have NYX Building Systems. Basically, think of it like npm packages and stuff like apt-get. Whenever you're using these things, often the developer just build the project for you and distribute it using these sources. And NYX tries to do reproducible, verifiable builds in a sense. Like you have like signatures and hashes about stuff, but it's still not perfect. And whenever you try to replay it, it might give you a slightly different output. And here's where things get to be interesting. Like you have Cartesi machine, which is a Linux environment, so it can run anything. So you can run NYX. And now if you run NYX inside Cartesi machine, you're definitely gonna have a reproducible build that is actually verifiable as well. So this can improve the quality and security of the internet overall. So for instance, as Firefox, for instance, distributes not only the Firefox browser, but the engine inside, they can say, hey, this is the build, this is the source. And we know we have here like the signatures of X amount of players, like let's say Google does it too, or Microsoft, and they also verify the build, and you can trust that that thing wasn't like by some chance somebody hacked Firefox servers and used their key to just sign a build and put a Trojan horse inside of the of the software. So you can it's it feels too weird when you talk about something like Firefox because it's too big. But day to day, we install so many little tools to make our projects possible that you don't really care too much about the security, but we should. We're seeing so many issues like with Python repositories, with NPM repositories being taken over. And this kind of thing can actually improve a lot, at least the concept, right? And then it can be applied with blockchain technology.
Yeah, I think this one is a bit abstract for. I need a bit of time to fully grasp it. But I think for me, what made it a bit clearer was like, you know, when you want to download stuff, you basically trust the website that you download it on. You maybe you trust the mirror because you have to download it from a mirror or whatever. So actually, how do you verify that what you're downloading is the original source code, right? And that's where stuff like NYX comes into play, and maybe also where Cartesi can take that to another level. This is great. Bugless is also sort of in this verifiable software category, and the key idea is really just doing, you know, how you have like bug bounty platforms where you submit, you know, how you cracked the a certain code base, and then, you know, the developer who submitted the initial bounty will pay you some money. You have to basically trust that developer or company or project will pay you the bounty that you deserve. With something like Bugless or like Cartesi in general, you can, in theory, you could have ways to basically prove that you were able to, you know, crack that system, hack that system, by submitting the exploit. Yeah, and then you can basically automatically get the money. So it's kind of like this permissionless way of doing. You know, anyone can just submit things that they want to test, and people can submit the ways in which they were able to crack those systems and automatically receive payouts if certain conditions are met.
Yeah, think of it like the Ultra Chess example. You had like the AI bots playing each other, but here instead of being a chess game, what you do is like you create some sort of sandbox and you create conditions for that. So, for instance, it can be VM itself, and you say like, you can not like change the amount of the balances of people because you don't have the key of these people. So, if you can do it, that means you cracked something. So by the end of the run, you can just do these checks and see what things you had as a guarantee. And if you break any of these guarantees, the software is checking it, right? So by the end of the execution, it knows for sure that you found something wrong with the software, and or you made it unresponsive. That's a possibility as well. And therefore, you need to receive the bounty. You don't need to wait for some human to verify your code. It's crazy. Yeah, it's crazy.
Sweet. 𝗵𝗶𝗴𝗵. So this is, yeah, basically bringing SimCity on chain, making it verifiable, right? Again, taking in an existing code base and you know, just porting it. Yeah, Raul,
With
you
that
wanna?
crypto, oh, but that there is a crypto economy around it too, man.
Sure.
So
Do
first
something.
thing, what did Cartesi help Danilo here? He could just port the game. The game was originally written in C and was ported to C++ in 2008 and made free software. So he just got the engine like as it basically as it was on 80 something, 90 something when they first released it, and he just ran. Now he did some smaller modifications on the APIs of the game, so meaning the external, like keyboard and mouse and screen stuff, not changing the gaming logic at all, and added a layer of crypto incentives to it. So basically, to start the game, you have to deposit some money, and you have to develop your city, and basically the internal money of the city has now a pairing to the deposit money, but everybody's playing the game as well. So in a way, if you forget about the game, it's like you're trying to steal everybody else's money. But when it comes to the game, you really want to develop the best your country. so you can have the most money inside your government. So whenever you're trying to make a withdrawal, you had more money than what you deposited earlier. So he created like this adversarial crypto economics to the game that makes everything more exciting, actually.
Yo, where can I go play this?
He made a testnet deployment. You can start bugging him on Discord, like, hey Danilo, drop your stuff you're doing for Cartesi and just like just deploy this game, man.
That's epic.
I really liked it, man. And he was a finalist on ETH Global Online.
True. That was awesome. I think this might be one of the last ones, but at least from this presentation deck. But yeah, it's Doom, right? Like the famous game is obviously always like, oh, will it run Doom? Well, yeah. So something like Cartesi can run Doom, basically verify, right? You know, using the inputs of the keyboard, it can basically replay the game at any time and check if the score that you claim to have received is the right one or not. So you basically have a verifiable Doom, which also, yeah, is super sick. And this you could apply to basically any like sort of game, retro game. You know, it's a bit easier on the single player side right now. You know, there's a framework being built that makes it easy to just sort of port existing games and make them verifiable. And obviously Doom is sort of one of the first ones that we demoed, but could be much broader.
For anybody interested in playing that, I actually put a Vercel app just with everything necessary to play. You can play it on your browser right now. You just go to world-arcade.vercel.app. It's just the developer sites they give you for free. And right now you can just play verifiable Doom, which is crazy, man. You play it on your browser, we sum up all the inputs and then send it to the blockchain. What it does, it's basically replay everything inside the gaming engine on the Cartesi machine and verify that you got the same scores, the same amount of kills and stuff. It's interesting that it can be done in the future is basically compensation for like maybe prizes for speed runs. Right now, speed runs are basically screen recording. But with this kind of stuff, you can really like just replay the whole game as it was played earlier. It's crazy.
Yeah, it's mad. And yeah, I mean, I think that's it. We have a page where we put most projects. So if someone wants to check, go dive deeper into like the repositories, the descriptions, there's way more sort of experimentation going on the website and on Discord as well. So that's it from the presentation side. Robbie, any thoughts? I hope we didn't bombard you with too much.
No, this was great. This is like so much inspiration about like what we're gonna see in the future and like what we can do on chain and why. So I think my question is around like when you're running something like Doom or any on-chain game, there's so many transactions that end up going through the blockchain. So all of that transaction throughput ends up going on chain. And like my classical like 30 IQ like understanding of transaction throughput is that you have like the scalability trilemma, right? So you have like speed, cost, and security. And for running something like Doom, like there's a lot of speed and there's a very low cost of running transactions. Are you guys making trade-offs like with security, or is there like some other way to think about scalability than the scalability trilemma?
I don't say there is a trade-off exactly. I think that's true to every rollup, and it becomes especially true for application-specific rollups. What you have is a kind of like it's crypto economics incentivizing people in a way that maintains everything secure. So as we play a rollup, if you go, for instance, for Optimism or Arbitrum, what you see is like for now, yes, you have a main node there, but eventually you should have like a bunch of nodes, and effectively what you see is like reproducing whatever mainnet is already is, many nodes verifying everything. But with application-specific rollups, you basically create these cliques where only the interested parties are together, right? Let's say we start playing a game, we are only 3. So only we are really running the rollups. But then here's when things start getting interesting. So if you just look at this scenario right now, you'd say, okay, so you compromise security in order to have more speed. It depends even how you put it, because you can say you compromise decentralization in this case.
Mhm.
But then security, how does security goes here, right? But then for sure you have the throughput to deal with the application, right?
Mhm.
However, different from a layer 1 network, we don't need to go for a majority consensus.
Right.
What happens is, let's say I win a game against you guys, and there's a lot of money on the table. You to say that maybe you won and split the money with Max behind the scenes. In a majority game, I would be like screwed, right? However, I can really just go back to Ethereum and use Ethereum as a judge and say, hey, I actually won, and here's the proof. And then it would enforce, even though I was a minority. And here's where crypto economics come in play. You probably have something to lose. So if you know Ethereum is there to always like protect me, and at the same time you have something to lose if you lose the dispute on chain, then you likely are not gonna do anything wrong unless there is a mistake on your software, but not maliciously, right?
Yeah.
So in that sense, you gain back the security, and the
Mhm.
decentralization kind of starts become more distribution. So distributed computing. Really only cliques of people interested in that computation should be running it. There's no necessity for like everybody to go for that. And still permissionless. So that means like, okay, now I talked about a table game with you here, but what if it is like an ever running application like DCA Monster, for instance? Maybe I'm making some trades, I'm interested, but then like next week I'm not. I can just get out of that, right?
Mhm.
So people can get in and out, and maybe you can even add more layers of incentivization where, okay, maybe I'm not playing with DCA Monster, but I'm verifying here and there, like on and off. And if I see something wrong, I dispute the original validators to get some prize out of that. That's how I guess most rollups and most specifically the application specific ones get to be this how to say this bridge between
Mhm.
what was Web 2 and what is Web 3.
Yeah, that makes sense. And you can pick and choose which environment to verify or validate.
Yep,
And
yep.
and those
But then
environments, those are applications that are built on their own roll-up environment.
exactly, exactly. So the dApp now it's not some bytecodes you're sending to the chain anymore. The dApp is the rollup itself. Like to run the rollup this in a decentralized fashion, meaning you're not pinging some AWS server. You're actually downloading, like for instance, a Docker image and running it on your machine. It's like a whole node. Um, but then there was one point you touched that was interesting and still like I guess a mission for the whole community to solve, which is the transaction data itself. So for instance, Doom is a very simple game, and it was really simple to make the input small, even for large sessions of gameplay. But what if it is really like heavy data stuff? What if you're trying to do some data analysis on chain for some reason? Then it becomes an issue again. And we still haven't figured it out that really clearly. Many projects are tackling the data availability problem and still not solved, I guess. And that's where we are at right now. Mostly CPU scaling.
No, I mean
Got
there
it.
is some data availability stuff too, but like
Yeah, but I mean like as a roll-up tech
yeah,
itself,
yeah,
yeah.
true, that's true.
What we figured it out was the CPU scaling part of it.
Cool. Stay tuned for the next video. We'll talk more about data availability and some more of the technical elements of Cartesi.
Awesome.
It was great.
Sweet. Thanks for coming on, guys. This was fun.
Yeah.
Thanks
You're
for having
welcome,
us.
man.